Assalamu alaikum. Good evening, good afternoon, masa al khair, good morning, everybody. Welcome to this session on the power of BigQuery, democratizing machine learning and data analytics. First and foremost, I'd like to thank GTG MENA for the invitation. I feel very privileged to be a part of this program. The team are doing absolutely amazing job with this technical days and digital days. I've learned a lot from the last few months. I've been following the program. Thank you so much for that. My name is Nabil. I am Director Training for Google Cloud for a company called Jellyfish for the Middle East. We based here in the UAE. I'm also part of the GDG Cloud Emirates here in the UAE, and hopefully. We will benefit from each other today throughout my presentation, throughout your questions, and yes, welcome everybody. So let's get started. So the explosion of data. So this is quite an insight from McKinsey. This is quite, I think, from a couple of years ago, something like that. So over the past really decade, at this point, big data has become a big buzzword. And why do we care about dealing with large data sets to begin with? So this quote from McKinsey tells us a lot. As you can tell, this is one's like a little bit out of date, but I think the quote really still holds the same point at this time. So they say by 2020, some 50 billion smart devices will be connected along with additional billions of sensors. Quite scary, really, ensuring that global supply of data will continue to double every 2 years. We're nearly at the end of 2020 now. So I would be just curious to know how close this number actually were. I'm sure they overpassed by far. The explosion of data has been really taking everybody by no surprise, if I might say, and the data has been really large. People are collecting data for all the reasons. But the surprising thing about this is that regardless of how much data is being generated, only about 1% of that data is analyzed, and there are a lot of different reasons why we may not analyze data. Maybe it's because we don't have a purpose for it yet. We're probably gathering data like log data. As long as everything is working for us in the enterprise, we might not particularly care about what's in that log data. It could be because we don't know how to analyze the data. We don't have that expertise. We don't have skills yet to deal with big data. Or maybe it's just unstructured data, like things like videos, like images, like sound files. And we don't quite have the knowledge of how to progress or how to analyze that data. And it might even be that we don't have the resources to process that data. And with that explosion of data, obviously, we're talking about terabytes, petabytes of data, and large scale, comes a lot of challenges to specifically to data engineers. They are the first point of kind of contact when we deal with big data. So they have to deal with that scale of data. So what we're going to do in this session is highlight some of those challenges and basically talk through of some of the tools that are available with us in Google Cloud in particular that could help us basically deal with those challenges and see how we kind of those tools can help us to be able to analyze data, to get more insights into our data without kind of being so technical, without being so learning the new skills and so on and so forth. So what are some of these data engineering challenges that we must address? First, we need to be able to access the data. So to do anything with it in practice, the data may be sitting in multiple locations, multiple countries, multiple data centers, and you will need kind of a permission to various stores to bring it together or transform the data into the form that is needed to get insights from it. And second, you will have to also worry about data quality. So if you plan, for example, to build machine learning models, for example, data accuracy and quality is very, very important. Machine learning, at the end of the day, is absolutely garbage in and garbage out. A lot of data that needs to be in good quality in order to have good models. And third is the availability of computational resources. Well, even if you have access to the data and the data is high quality, you have to be able to process it. You need to have access to these resources, to these big servers, to this kind of infrastructure in order to process that data. And then finally, we want to be able to optimize query performance, because you need to analyze data. Surely you're going to be running some queries, some filters, to be able to run all these queries and transformations that we need with the computational resources that we have. Then we need to be able to optimize whatever query engine we are using, whatever resources we are using, and so on and so forth. So if you're managing, for example, on-premises data center, you are in your own data center, and for example, you have a data analytics cluster. So what will you be responsible for? You will be responsible for, first of all, choosing a query engine. So for example, if you are running a Hadoop locally at your data center, do you want to use something like Spark SQL? Do you want to use Hive? Do you want so you have to make those choices as appropriately as possible to have efficient system in place. You will have to worry about patching your cluster, updating query engine software, managing the clusters, and when to basically recluster when you need more resources. For example, it might be that the software that you're using as part of the query engine, it's a new version that the hardware doesn't support anymore. You need to upgrade that hardware. So you need to have new servers. You need to have to reconfigure the cluster. You need to add more resources and so on and so on. So you need to pull in compute and more memory, more storage. And then finally, we want to optimize for concurrent queries and maybe set up things like quotas and things like in order to have this balanced demand if you have multiple teams, for example. So it's possible that you might have one team that needs a lot more resources than other teams. So you want to be able to give them the right amount of resources without kind of blocking other teams and striving other teams from resources. So they will be waiting for those resources in order to have insight into that data. So all that stuff you will have to manage yourself. And that's what you end up with is, so if you are on-premise system, again, data engineers will need to manage the server, the cluster capacity, make sure that they have enough capacity to carry out those jobs, whatever processing jobs they are doing, whatever queries they need to run, whatever analytics they need to do. And the problem is that the compute needed by these processing jobs are not going to be constant over time. So it can vary week by week. So you can see on this slide the variation of consumption against capacity. It could be month by month, maybe even day by day. But then we have an issue of consumption versus capacity. So for example, maybe here on the left, you will have we see that we are underutilizing our resources. So we're paying for resources that we are not using. However, a little bit later, we run across the issue of we have a spike in consumption. So, and we are under provision. So we are now waiting. We are wasting time to try to get to our insights. And in some situation, this could be critical. So if, for example, you're doing some analytics for tomorrow, you've got some business decision to do, then this wasting time is critical to the business. So you don't want to be waiting for those resources because business is critical and decision making is waiting on those kind of insights in order to make the right decisions for the business. And this is basically what BigQuery will come in to help us with dealing with those challenges. So BigQuery is basically a data warehouse solution. It replaces a typical data warehouse hardware setup. There is no hardware for you to set up, though. And one way people like to think of it is that it's like a data mart that is organizing your data in tables, into units. And this is what we call data sets in Google Cloud BigQuery. And we'll get into this a little bit more later. So BigQuery is not a data lake. That's for sure. You need to be clear about. It cannot handle unstructured data, at least in a reasonable way. However, it connects nicely with data lake solution like any data storage, like Google Cloud Storage, for example, or even Google Drive. So you can use BigQuery to define schemas on, say, for example, you can do it on Google Sheets, and then basically have a federated query to issue queries directly against the Google Sheet if you wanted to. So if you are used to working with traditional data warehouse and you worked with tables and views and normal SQL statements and all that, that works exactly the same. And then what about things like grants, controlling who have access to what? And this is what we have in Google Cloud, what is called Cloud IAM, Identity and Access Management, comes into play, and it's really nicely integrated with this, and will allow you to give grants and permissions to whoever uses whichever groups you want to do that. And ultimately, what the goal is basically we using serverless technology on the cloud. Is that we don't want to have to put a lot of our time and resources into looking after a cluster, into looking after hardware, into things like trying to improve the query processing, to tune our performance, to do monitoring, to do reliability, to do patching, to do utilization improvement, and all that. All what we get with BigQuery is focus on insights. Anything else is managed for us. We just need to focus on our data analytics and use the service and pay as we go. So there is no kind of upfront investment that we do, like we're going to see. And you don't need to provision resources before using BigQuery, like I said. So this is something that's really nice about BigQuery. BigQuery allocates storage and it allocates query resources dynamically based on your usage patterns. So there is this intelligence that machine learning models that run in the background that according to your usage, it will exactly when you put a query in, it will know how much storage you're going to use, what kind of compute you're going to need, and it will give you exactly the resources that you need, but based on your historical kind of pattern that you've been using. So in this case, we get the advantage of we're not over provisioning or under provisioning at any point. We are leveraging Google hardware, Google infrastructure, and technology. So we'll come back to BigQuery more in full details throughout these sessions. So once again, I'm just kind of giving a high level overview, but once again, we really dive into the details on how we use BigQuery, how do we store data in BigQuery, and so forth. So again, what is BigQuery? Once again, it's a petabyte scale, fully managed data warehouse, and I actually prefer the term serverless. So we don't need to spin up a cluster to host our data or run queries. We simply tell BigQuery that we want to store this data. We tell BigQuery we want to run these queries, and it manages all the infrastructure behind the scenes. The pricing model, I'm not doing a sales pitch here, but to give you an idea, you're not doing upfront investment into hardware, into anything. You just use on demand. So you can do an on demand at the level of around, if I'm not mistaken, $5 a terabyte, and 2 cents per gigabyte per month for storage. It's quite cheap. Or you can take advantage if you are a very heavy user of BigQuery. By the time you're doing a lot of analytics on petabyte scale of data, you can take advantage of what is called flat rate plans, and those they work out at I think around $10K for every 500 slots. We will talk about slots in a minute. So but what you're doing at that scale, those really come into play once you're analyzing petabytes of data per month. So you don't go to this flat rate plan unless you are really big on analytics and using petabyte of stuff to analyze. And you have all the things like the encryption, the security that you expect anywhere on Google Cloud, and they come as free. There's no extra cost for that. And we'll say more about when we talk about how data is stored. But we have some kind of other capabilities that are really neat as well. Things like, for example, we can work with geospatial data types and functions, so GIS capabilities. We can also use this as a foundation for machine learning and business intelligence, like we're going to see as well. So again, this kind of bullet points of the of BigQuery, what it can give us. So fully managed enterprise data warehouse. It provides you with this real kind of real-time interactive analysis of massive data sets. And it runs on Google's fully managed, secure, high-performance infrastructure. The same infrastructure that is running the things like the Gmail, the YouTube, all the And by the way, the Google, they have, I think now they have 8 applications that have 1 billion plus users, active users for each. So you can imagine the infrastructure they are using for those applications, they are exactly the same that we are talking about here. BigQuery is leveraging the same infrastructure that runs those applications. So it's reliable. So data is replicated across multiple data centers. Very economical. You don't have to like I say, to do any upfront investment, and to do petabyte of analytics, you need a very expensive hardware to run this kind of analytics. So you only pay for storage and the processing that you are using. Security is secured through, like I said, things like access control list, identity and access management. That's in GCP. Data is encrypted at rest in transit at no extra cost. For auditing, Google Cloud Audit logs, they track the admin activity, the data access, and the most important things about this is the logs are immutable. You can't change them. So you know who did what at what time and when in BigQuery. So and it's scalable. So virtually you have unlimited data storage and processing power, a highly parallel and distributed processing model. So powerful, flexible. So you can do streaming and batch. You can do join cross diverse data sets and projects, and easy to use. So you'll have things like data stored in denormalized data. So like simple schemas. The storage is based on columns. We talk for high performance. We're going to talk about that in a minute. So you don't need any indexes or keys. If you are familiar with basic SQL, you off to go. You can use a very intuitive UI, user interface, and many other things. So it supports open standards for SQL, like I said, and analysts can use preferred tools if they wanted to as well to connect to it. So it's time to get a little bit kind of more technical here. So how does BigQuery actually work? So it's actually two services. So one service that I hinted at a little bit earlier. So it is a fast SQL query engine, and also a fully managed storage layer for loading and storing your data sets. And keep in mind that it's serverless. So you don't have to create any of those things, meaning that it's fully managed for you. Google will do all the things. You just bring your query, your analysis that you want to give it to BigQuery, and the rest is done for you. So you don't see this managed storage piece. It just works behind the scenes. Data, it replicates your data across multiple regions, multiple data centers, and all this kind of mapping of data and servers, and which pieces of data goes to which data center, and the encryption, the security is all kind of come as one of the services for BigQuery. So we talked about storage and compute as two services. So the query service is basically compute, the memory and CPU that run the query. So how did we get to this? How did Google get to this concept of kind of putting a service and decoupling the compute and the data into two different services? Usually when you are on premises, you will have servers, you will have disks in them, and you're processing the data that's on the servers. Google have thought strategically in a different way. They're decoupling the compute from the storage. So within Google data centers, how did they manage to do that? Is this investment of in the networking piece of Google Cloud. So here we're talking about a bisection bandwidth of a petabit per second. So what does that mean? It doesn't mean that in a Google data center you will have a single network connection that can carry a petabit per second. I don't think that physically exists. Rather than which it means is that if we think of a data center as kind of one big network, and we cut it into half, and for example, let's add up the network speeds across all the connections that we cut, and do that in the worst possible way, the most restrictive way for the network, so it will be cut into halves. That number that you get from the connections from one side to the other is a petabit per second, and this is like massive. It's like insane connectivity. So we can, with that, what you can do, you can move data extremely quickly from storage to compute with the minimum latency, and within the actual data center itself, the individual connections you can shuffle data between different workers, between different servers at over 10 gigabits per second. So separating compute and storage is more cost efficient. And strictly speaking, there is a little bit of latency, but that latency is insignificant because of the network speeds. So what this allows you to do is if I need more kind of compute to deal with my data, I don't have to add servers with storage on them, because what I need to do, we need to reconfigure my cluster. Rather, I'm just going to give it compute and memory. So it's just VMs without basically without any storage, and my storage is separate. So and I bring in the data because I've got a petabit per second bisection network. So it will feel like I'm having data locally. So we have storage service and query service, which are separated by this network. So your data is stored and compute is brought to the data in the form of these slots. So slots meaning just VMs. That's what we call them in BigQuery. So how is it stored in Google Cloud? So all the resources on Google Cloud must lie in what is called a project. So whatever resource, a VM, whatever serverless service, whatever, you need to create a project, and the project is the container where you put all the service. BigQuery is no different. So you need a project. You leverage the BigQuery service into projects, and within a project you have what is called data sets. So once again, data sets you can think of as a high-level container, an abstraction of where you're going to put your data for your data and objects in BigQuery, and then within a data set you can have things like tables, you can have like views, stored procedures, and we will see a little bit later. You can even have machine learning models, and this is one of the capabilities that we're going to talk about a little bit later. And then all this data lives in what is called the Colossus file system. This is the storage of Google. They use it for Bigtable, they use it for Gmail, they use it, all the storage is very sophisticated. The same storage that is underneath all the services that Google uses. So this storage service, it supports bulk data ingest and streaming. So you can stream data to it. You can bring data in bulk if you're importing data. So it can work with huge amounts of data, and also real-time data streams at petabyte scale. So once our data is in BigQuery, when we do that, there are kind of, we can basically query that data. So simple SQL statements like any other SQL. And there are three different ways we can submit queries. We can use the web UI, which we'll be using in our demos shortly. We can use a command line, which there's a BQ command line tool. So just like other services in Google Cloud, they've got other command lines. BQ is specifically for BigQuery, and then finally we can access it also via REST APIs. So we can do this with many different client languages. In this slide, it says 7. Actually, I believe the number is higher now. I think it's 8. But the main ones that you see being used for data analysis, data science, things like Python, things like Java, JavaScript, Go, etc. All those kind of things are supported with the APIs for Google. But your data doesn't actually have to live in BigQuery. So ideally, best practice is to have it in BigQuery, but it's not also. So you can do federated queries, for example. You can have CSV files placed in cloud storage or Google Drive. So you can set up these connectors to other kind of services, and you can query your data there as well. So the second thing that we said that BigQuery was a managed storage service. So if we want the absolute best performance, you load the data into BigQuery. You use the storage that in BigQuery. Even though I said we can use federated queries, but the best performance you get it with once you if you use the storage that is the service of BigQuery. But sometimes, whatever file format you have, as long as it's something supported by BigQuery, you load your data into BigQuery and use the query engine on the data within BigQuery. So two reasons for that. One is more time efficient, so you don't have to load data into BigQuery, go through all that process. Instead, it's already loaded for you. Even for when you query CSV file from, for example, for example, that data needs to be loaded at least temporary. The second is that your data in BigQuery is stored what is known columns. So this storage is Colossus storage system. It's got like columns, so you can store your data in columns, and that what helps. It makes it more efficient. So if you do select statements on particular columns, you just bring in those columns and you make it very, very fast. You make it very, very cheap. So you're not bringing all the columns, all the rows of your data. So you need to, and you only need to process the columns that you need. So this is one of the things that we need to mention, that in BigQuery, it's also good reason for best practice to never use, if you're familiar with a SQL, to use a select star. When you do select star, you bring in all your data into the storage. It costs you, you ingest in a lot of data into your storage. It costs you a lot of money, more money, I would say. But as I said, you don't have to load your data into your BigQuery. You can do these federated queries, and this specifically, if, for example, using transactional database that you want to query data from, obviously the data on the transaction database is kind of changing very frequently. So if you were to load the data into BigQuery, you will be doing that every 5 minutes, maybe every 2 minutes, and it becomes it's not efficient way to do things. So if your data is changing frequently, federated queries is the best practice in here. But in general, if you don't have this case, then load your data in BigQuery to have it more efficient. And let's have a look at kind of a quick demo to see how this works. So if I go to, let me see if there is any questions. Okay, I don't see any questions. So let's have a look at, so BigQuery, you can use it from here. So this is the BigQuery. As I said, it's just like a UI. Let me clear this, compose a new query. So it's just a UI. You just bring your select statements here, and you're ready to go. You're ready to run your queries. So one of the queries that I use for my demos in my training is querying kind of billion of records from the Wikipedia dataset, which is a public dataset that Google are make available just for these kind of purposes. So here, for example, I've got a dataset called BigQuery samples, Wikipedia benchmark wiki 1 million records. So I'm just want to select language and the title and basically the sum of views, and I'm gonna query the word Google and any searches for that. So just to show you what this query is about, if I just show you here. So it gives you basically the schema, what the schema is about, and the details. So the table size, 86 megabytes, not too bad. Number of rows, 1 million and a quarter, pretty reasonable. As soon as I put my query here, it's telling me this is how much it's gonna process in terms of storage, 53 megabytes. So if I run this, 0.9 seconds elapsed time, processing 53 megabytes. You might say, okay, it's good. I can do that on-prem. Absolutely fine. Let's move to another data set. We're looking at 100 million records. So just to show you this data set. So here we're talking about another data set. If I have a look at it here. So the details talking about a table size, 8.41 gigabytes. We're looking at 125 million nearly records that we're going to query in that. We're going to be processing 5.2 roughly gigabytes when we run it. Let's see how long it's going to take to run this query. Not bad at all. 2.9 seconds elapsed for querying 125 million records, which is really, really powerful. Let's have a look at 1 billion records. So the same schema, except we've got the table size. This is one table in dataset, 84 gigabytes. We're talking now 1 billion and a quarter, 249 million. Now we're talking about 50 gigabyte running this query. So let's have a look what is it gonna come back with. Nine seconds to query 1 billion records. Let's have a look at some execution details to understand more of the features of BigQuery here. So it's telling us the elapsed time is 9 seconds. The slot time is 16 minutes. What does that mean? What that means is if I were to use one server out of the servers that Google BigQuery has given me to run this query, it would have taken 16 minutes to run. So if I want to know, this is the intelligence that behind BigQuery. It's giving me more servers to run this query without me asking for these numbers. So it just realized that I've got what did we say? 10 billion in this case. 1 billion. 1 billion records. It gave me the right resources that I need, the right kind of slots, VMs, the service that I need to run this query. So remember, this is 9 seconds, and I'm gonna run one last one. I'm gonna move it to 10 billion records. Okay. Just to show you the details, we're talking about a table size of over 0.5 terabytes, and we're talking nearly 11 billion records here. So the other one, it did it in 9 seconds. Let's have a look how long this is going to take us to leverage the BigQuery service to run this query. "12 seconds. You would have thought, because the other one was 1 billion and the other one 10 billion, you would have thought it will take 10 times more. But this is the intelligence of BigQuery. BigQuery already knows that I've got a pattern that I'm using. Let's see on the execution details. It's taking 11 seconds to run this. And the slot time, if I were to use one server, it would have taken me 2.5 hours. Now, BigQuery is intelligent enough to tell, look, this guy is using a serious amount of like a data set to query. I need to give him more servers to run this query in the most efficient time. So that's why it's the other one. 1 billion is 9 seconds. Now this is 10 billion is 11 seconds, 2 seconds difference. And the other one, it was something like, I can't remember, 9 minutes, 16 minutes to run if I was one server. This is if I was one server, it's 2 hours, 31 minutes. The other features that I'm just going to touch on those. Obviously, we're just scratching the surface here. We just see that what kind of things we can do with BigQuery. Let me see. There's a feature here called cached results. So the first time it takes 11 seconds. If I were to run this query again, it's running in 0 seconds. It came back very, very quickly. The reason behind it is it's using the cache. So when I run a query, BigQuery will go and cache my results and keep them for 24 hours. And it's intelligent enough to, if I run this query again, it's going to give me those results, unless two things happen. If the data changes, it will invalidate that cache. You say, okay, you've got fresh data. If you query that data, it's wrong. So I will have to run from scratch, or it will leave it for 24 hours because there are other queries that are run through the day that's going to use the cache. So it's intelligent enough to make that decisions for us. So this is kind of democratizing data analytics with BigQuery. You only need to know SQL and leverage the power of the infrastructure that BigQuery is using and get those analytics, those insights very, very quickly in a matter of seconds. And let me go back to talk about other things here. BigQuery ML. So what Google they did, they taken kind of the BigQuery capabilities to another level. And this is what we mean by democratizing machine learning. So you don't have to be a machine learning engineer in order to have your machine to do machine learning models, create models, and do kind of predictive analytics and things like that. So let's talk a little bit introduction to machine learning before how we integrate it with BigQuery. So the popular imagination of kind of what a machine learning is that we have kind of loads of data, and then And then we do some very, very kind of complicated mathematics in these high dimensional, multi-dimensional spaces. And then we get these magical results. It's as simple as that. The reality is not that. In practice, it is much more difficult than that. It's really a long process that starts with collecting data. And then you need to, it's very hard to do any sort of kind of supervised machine learning or unsupervised without data. So you need data, you need loads of it, and you need very high quality. You need to be clean and high quality, and then you need to organize that data. So for the machine learning, data has to be formatted in certain ways for certain machine learning algorithms. So organizing the data and getting our data in such a format that we actually then train. We get to train, create a model and experiment with it and train that model. Sometimes 9 out of 10, our first model is not gonna be good. So we need to go back, look at the model here, look at our data, maybe add some features, maybe collect more data. Maybe the data is not enough. Maybe we need more data and things like that. So we need to kind of repeat this process so many times in order to improve the results. So, and then at the end to get this magical result. So really the point here is that the machine learning process, it is a long process. It's a tedious and a long workflow. It's not that we can't just take data and throw it at something and expect those magical results. It's more tedious than that. So and when we hear about things like artificial intelligence or machine learning, usually we don't make a difference. So artificial intelligence is a field. So it's like physics, it's like chemistry, it's like mathematics. So it's a field, and the field is focused on creating machines, if you like, that can think and act like humans. Machine learning is a specific way of solving these AI problems, but it's not the only way. For example, we have expert systems. They are a way of solving these AI problems. And the other thing is, when we think about artificial intelligence and machine learning, we only think about those applications that deals with photos, with videos, and we have in our phones, or these applications that are on our phone when we the smart reply, for example, in Gmail, which are like the sequence models, they call them. But we don't think about structured data. So in Google, for example, the majority of the machine learning models they have are actually unstructured data, not structured data like images, text, and video, and so forth. They have only 5%, but otherwise you will have the MLPs, the multi-layer perceptron, for example, which is like deep neural networks. That takes 61%. It's basically machine learning unstructured data. You have the LSTMs, which are the long short-term memory. So this is like the sequence models. It takes 29% of that. And the CNN, the convolutional neural networks, refers to here we're talking about image models and things. They're only 5%. The point here is there's 61% structured data, and that's a lot. So the point I want to make here is machine learning on structured data. It's a field that is growing. There's a lot happening in there. It's not just about images and these fancy applications that we see. So it's very important to have machine learning on structured data. So when we wanted to do machine learning, we don't want to manually write rules. We want our model to learn from examples. So what are examples? So here, when we're working with structured data. So let's have a look at that. So let's talk through a quick example. Let's try to in this example I'm going to show you, predict the customer lifetime by the machine learning model. And with that, we'll be using this a public data set. We'll be using Google Merchandise Store, which is publicly available. And obviously, things have been properly anonymized, so you don't have to worry about like specific data for private data for people. So, for example, the visitor ID is just a hash, so you don't know what does it mean. So here we have information like visitor ID, distinct days visited, LTV page views, LTV visits. So multiple information that we can use in our machine learning model. So some of the terminology that we're going to be hearing, so machine learning terms. So what is an example? So an example is one of the terms we use in machine learning. You will hear the term, for example, instead of an example, you will have observation or even an instance. And examples are the full row of data. So when we're talking about structured data, or example, the example is the entire row of our data. So that's what an example is. And then we hear things like what we're trying to predict for a specific column, for example. And this is what we call label. So here we're trying to predict the lifetime revenue, and we want to predict it as a numeric value. So this is an example of what we call forecasting or a regression model, because we're trying to predict a continuous number, a floating number where the magnitude is basically meaningful. So if the lifetime revenue of one customer is double than the another, that multiple of 2 really means something significant. Or if we sometimes we don't have to predict a numeric value. We could predict instead a category. So for example here, high value customer or not high value customer. So it's like a discrete class, like I said here. So this is like a classification problem or classification model. So if we're trying to predict a number or a discrete class, this does have an influence over what type of model you may want to use, and we will get more into that in a little bit. So what about the other columns? So we said there is a label, there is the example that we talked about. How about the other columns that we're talking about? So this is what we call features, or sometimes we'll hear the term feature columns. So our feature columns here are all the columns that are not labeled. So it's not something that we want to predict. So as a note, not all these features we would want to possibly use. For example, the full visitor ID has no influence over predicting kind of what kind of customer it is. And what if we don't know where a new customer will fit in, if it's high value or not high value? And that's exactly what we want to train a machine learning model to tell us if a new customer comes in, according to this data here, to have this prediction whether it's going to be a high value customer or not. And we want to be able to predict or infer what would be the right class for that customer, either high value or not for new customer. This is the aim of the model. And so if you are using something like linear classification model, which is one of the types that we can use in BigQuery, in particular things like logistic regression, it's kind of a type of a linear classification. So you will be assigning what is called the weight to each of the features, and the more the weight of the feature, the more significant, the more impact the column has, the higher is the weight that we associate with it. For example, here we say distinct days visited. So the more here we can see that the more the customer is visiting the online store, the more probability, the more chance that he's going to purchase, and that's why we put in a weighing factor that is high here. And the opposite, if it's high but in minus, that means if, for example, I have I don't know, page views, average session, first visit, for example, the date of the first visit, for example, and I have it minus 0.7. Well, what that means is it is of high significance, but in the opposite direction, meaning it has no very kind of impact, or it doesn't impact the kind of if the customer is going to buy again or not, if it's going to be high value customer or not. And here are kind of some machine learning terminology. So there's a little bit review here. So when you say term label, this is what we're trying to predict the correct answer, typically from historical data. Features are the other columns of data that we want to model, to learn from. And the model, what is a model? The model, I'm going to phrase it a little bit differently what's on the slide. So a model, I would say, is a mathematical function that where we take the features are our input, and by combining it with weights in some fashion, depending on the type of model, we get a prediction of our label. So this is basically what a model. And then we have the evaluation, we have the prediction, and so on and so forth. So this is briefly about machine learning and some kind of background of for structured data specifically. So how does BigQuery machine learning fit in? So in practice, when you do your model yourself, it can take days to even months to create a really good model that you're ready to put into production. And lots of times the workflow on Google Cloud with structured data is we have our data, we're in BigQuery. You will pre-process it, you will export it into kind of cloud storage. Then you use you train your data using something like TensorFlow. You evaluate that, you export the data again, and so on and so forth. So it's like the process that we talked about earlier. So it's the full kind of with machine learning with BigQuery ML, we can skip a lot of these steps and train the models directly within BigQuery. So that is BigQuery ML. So somewhere in between here, with the AI capabilities in GCP, we'll have perception APIs, completely hands-off in terms of machine learning. So you can just leverage them. They are pre-trained model. And with BigQuery, you have pre-trained models. So you get a lot of ease of using these are kind of pre-trained models. So you're writing models just using SQL queries, which is amazing. So without having to dive into the coding of Python or TensorFlow or anything like that. So you don't have full control for sure that you have with TensorFlow, but you may not need it for your application. And that's what BigQuery ML will give you. So you know that building machine learning can be very time intensive. You first must export small amount of data from BigQuery into things like Pandas or Data Lab. And then you transform the data to be used in TensorFlow, if you are familiar with that. You build the model in TensorFlow, you train your data locally or on a virtual machine, and you need to know what kind of hardware that I'm going to use in, what kind of CPUs, TPUs, OPUs, all that. And doing that, you will manage all the hardware as well. So you are managing all that. So it's like a burden to do that as well. Doing that with a small model, that then requires that you go back and get more data to create new features and improve performance, repeat. It's really hard, it's really tedious. So, and basically a lot of iterations. So when you're working with BigQuery ML, there are absolutely 4 steps only. So the first, you will your data set. So your data needs to be referenceable within data set in BigQuery. So it's used you couldn't use the BigQuery ML on external tables, like for example CSVs in external sources, but now it's changed, so you can use that as well. So regardless, you're going to need to create a table, internal, external, within BigQuery. Second, you can create and train your model. So this was a simple create model statement, like we're going to see in an example. And we specify the type of model, regression, and there are many types that are available in BigQuery ML. And then we evaluate our model just with the ML from ML evaluate, and you create a table for your evaluation. And then finally, for number 4 here, you predict and classify. So we do from ML predict model and the table that we want to serve the predictions, and you will have your predictions. So no coding whatsoever, just 4 simple statements in BigQuery ML. And this is what we talk in democratizing machine learning. You don't have to be a machine learning engineer. You don't have to know TensorFlow. You don't have to know Python or anything like that. Just those simple SQL statements, and you're ready to run your models. And when we talk about evaluation of the classification model performance, basically what you want to do is to minimize the false positive rate and maximize the true positive rate. And this relationship is known as the ROC, the receiver operating characteristic curve, like the one shown here, where you try to maximize basically the area that's under here. So this is the best one, that the best curve that you can. In BigQuery, ROC AUC is simply a field that you can query from the trained machine learning model. So it gives you that ready for you, so you don't have to run any scripts, any code or anything. You just select statement and it will give you that. And behind the scenes, like I said, with 2 lines of code, you're ready to run your model. And this is like a kind of the 4 bullet point overview. So here you're able to write machine learning models, but only with SQL, simple. You can experiment and iterate and write where your data lives in BigQuery. and then you can build classification, forecasting, recommendation models, all within BigQuery, without having to go and create any coding outside or anything. So if you know machine learning, you can turn some more of the dials that you may not have access to. Otherwise, you can have some of those capabilities to have more control on the weights, adjusting hyperparameters, and things like that. And this is like a cheat sheet of different kind of BigQuery ML kind of select statements and terms that are used there. And let me just see the time. If we have, I think we have time to have. Let's go back to just to show you how easy to create a model in BigQuery. So let me clear this, and I'm gonna compose a new. Okay, just see here. So we're gonna. I created the data set just to be ready for that. Let's see how we're gonna create a model. This is like for prediction of return visit from a store. So this is a simple create model. I gave it the name of the model, classification model, and then I select my features, that the fields that the bounces, meaning basically a user just came to the site and he just disappeared straight away, and the second one is the time he spent on the site. So we're using kind of those two features in order to have our model kind of predict if the user is going to come back or not. Okay, I did run this model. I did evaluate it just to see the ROC that we talked about earlier. So how do we see if that model is good or not? So it's just a select statement, like I said. This is to evaluate the model. So it's if that ROC is above 0.9, it's a good model. If it's above 0.8 is fair. If 0.7 is not great. So I can run that. So you can give me what my model is, if it's good or not. 0.7 is telling me it's not that great. Usually what happens with that is I need to add more features. So the next one that I'm doing is I need to add more features to make significant changes to my model. Now I'm doing all that inside BigQuery. I'm not going to any Python or any kind of data lab or anything like that. So this is my improved model. I'm just show you what we've done with that. So this is my classification model 2. We've seen that 2 kind of features is not enough. So I'm adding things like the behavior on so these are the 2 that I had before. Now I'm using another features like the visitor. What did he come from? What is the traffic source that he come from? What is the device? Is he coming from a mobile device? Is he coming from laptop? Is it a geographical area? What country is coming from? So I'm adding all these features in order to improve my model. And with that, when I trained my model, obviously I ran it early. It takes between, it's not hours, because I've got capabilities in BigQuery. I've got so much resources that Google can give me. I ran it earlier. It ran under 5 minutes. So when I evaluate the second model, and I see what I did with these features, I can just query the ROC IUC field to see what model my model is doing. So when I run the second model with more features, it's giving me a good model. So I can improve in no time, just adding these features as I go along, run my model again, and I can do my predictions. And with that, I run my second one, which is this model 2, and I get 0.9. So this is the kind of things that that I can do with leveraging the power of without having to be a machine learning engineer, without having to be a data scientist. I just need to learn those 3 or 4 commands in SQL, and I'm ready to do predictions. I'm ready to create machine learning models. I'm ready to in no time. So I've got like a cheat sheet to use. I've got my data clean and stuff, and I just create with a simple SQL system, create, evaluate, and predict my results. Simple as that. Not only that, Google are taking data analytics to and machine learning to another level, a level where we talk about natural language processing. Obviously, we know that Google Cloud, there is this AI APIs for natural language processing. So we know it's very powerful. Google, what they did, they brought this capability into BigQuery, where now what you can do, you can use natural language to get data analytics, to create queries. And this is what data Q&A is. So it's you can do Q&A is a fantastic exploration into what it looks like to try to democratize data analytics. So to a wider audience than those who are experts, let's say, in SQL or comfortable writing SQL statements. It is certainly not going to supersede the requirement for those experts in SQL, but it's going to complement access for users with no or minimal SQL experience. So you'll have analytics queries with through natural language questions, this semantic parsing and mapping to data sets up to petabytes in size. Again, because it's BigQuery, it's based on BigQuery, it's fully managed, it's serverless, it's encrypted, it's durable, and it provides this self-service access to analytics without. We've seen with BigQuery itself, you don't have to be technical about clusters, about VMs. This is taking it to another level. You don't even need to know about SQL at all. So let's have a look at that. So so this is what is called data Q&A. So with data Q&A, it's obviously this is still in alpha, so it's not public, it's not beta yet, it's not GA. So Google have given us access to it just to report on performance and use it for our trainings and things, and basically see what they're doing with the technology. So I've got my kind of my data here, so I can go. It's all set up. I can go to BigQuery. Let me new query. I can ask questions. So I can use what we're using here. We're going to use the US COVID data, and we're going to interrogate it just with simple natural language questions. So I would be doing something like which county has most number of cases? And I'm just gonna ask him to convert. So he's telling me you want the county by code or by name. So I'm just gonna say by name. So he's created the SQL for me from a natural language sentence, a question. I open this in the query, and I can just run my query. I don't know even what SQL means, and I get my results, and it gives me the top 10. So Los Angeles, for example. Let me ask another question. I'll make it some kind of bit more complicated than that. which state and county had most cases in the last, let's say, weird number, like 23 days, for example. Again, it's asking me for the county, do you want the code or the name? I prefer the name. I'm not familiar with the US codes, so I can open this. So he also figured it out. If I say 23 days, he's telling me from 27th till the 19th. This is your 23 days. Sum of confirmed cases, county name, state, sum confirmed. I can run my query. There you go. He gives me all the cases for the last 23 days. And you can see here some use cases for that. We've seen how COVID was very tough, and a lot of kind of politicians, they make this decision making on things like, are we going to close the country? Are we going to close the state? So imagine it's like a politician waiting for a data analyst going back, running this query, sending him an email, rather than he can give him this ask question and he can get the results. He can make decisions there and then. This is just a field. You can give it to medical field, for salespeople, to see how much they've done in a month, things like that, and let the experts deal with complicated cases. This is like querying data. Just give them this, and they will be. And you can also use it in Google Sheets. So if I go to Google Sheets, for example, what I can do with that, I can query my data. So imagine you have, I don't know, you have salespeople. What you can do, you can just go data, connectors. You connect to your BigQuery. My COVID data that I have. I'm connect to it, connecting to data. Okay. And I can ask question here. I can ask, let's say, cases, for example, by month in Kansas, for example. There you go. For each month, is giving me the number of cases for Kansas, for the state of cases. Let's say, very, very powerful. This is like a game changer in the data analytics. So it's taking it to another level. So number of confirmed if I can spell cases in, let's say, California, for example. There you go. It can give you even the formula. So this is the select statement that it used, and it gives you the results. Absolutely amazing. And when I saw it first time, I was just like, still, whenever I use it, I'm just like, so you can see the use cases that could be used. It's like a game changer in many, many industries. With COVID is a no-brainer. It's kind of make a big difference into those decisions on the spot to take decisions, whatever those might be in sales. You can it's open to many kind of opportunities, many kind of use cases. So this is the way it's going. This is where Google are doing the next technology, the next step in terms of BigQuery, opening this kind of capabilities that help democratize data analytics and machine learning. So we've seen BigQuery machine learning, and now we've seen this data Q&A, taking it to absolutely another level. And let me see here. So this is the demo that we have seen, and I think I've run 5 minutes more. So this is all I have for you. Thank you very much for your patience. If you have any questions, please feel free to put them in the. I can see if there's any questions. In Arabic is fine as well, so I can take those. Otherwise, if you, this is my email, this is my link there. You can send me questions later if you have anything. Feel free to connect to me on LinkedIn, things like that. So I tried as much as I can to showcase these capabilities. Obviously, we needed things like that. You need more hands-on. So watch for this space for GDG Cloud Emirates. We will have study jams. We'll have about data analytics, about cloud in general. So in the next few weeks and stuff. So keep connected to that, and obviously things like that. It needs a lot deep dive and training and stuff with us in Jellyfish. We do kind of more kind of deep dive data engineering training in BigQuery, data insights, or cloud infrastructure and things like that. So if you want to find out more, reach out to me. I'll help you with that as well. Let me see if there is any questions. Otherwise. Thank you so much. I will wait a couple of minutes if there is any questions. Otherwise, thank you so much. Thank you for your patience, and thank you for having me. Okay, as I said, I can't see any questions, so feel free to reach out. You're very welcome. Thank you so much, and salam alaikum.